All right, we've got a two-part problem here, Algebra 2, and working on the Topic 1 review. Getting up there, problem 23 out of 35. Quite a few problems here. I wouldn't expect most people would do all of them. When the air temperature reaches the dew point, fog may form. I've heard that before. And it also the clouds. Both the air temperature and the dew point decrease at a constant rate as the altitude above ground level increases. If the ground level temperature and the dew point are T0 and D0 respectively, the air temperature at an altitude of X miles can be approximated. So that formula, I think, is what's important here. The air temperature at an altitude of X. So the air temperature at an altitude of X miles above can be calculated by taking whatever the T0, the ground level temperature is, minus 19 times X, however many miles you are above the ground. And then the dew point can be calculated by a similar formula where whatever the dew point is on the ground minus 5.8 times however many miles above the ground you are. So there's your formula. Suppose that the ground level temperature is 61. That's this right here. It's your T0. And that the dew point at the ground level is 44. So that's that D0. Note the clouds will not form at altitudes for which the air temperature is above the dew point. And that's kind of just what the way dew point works in temperature or clouds. All right, so the altitudes at which clouds will not form. So we're talking about that last comment. Note that clouds will not form at altitudes for which air temperature is above the dew point. So we want to know when these two things are equal. And then the altitudes at which clouds will not form is below that number of miles. So let's solve this and see what we get. So let's see. I'm thinking if I add the 19 over there, that'll make it positive. I like to keep my numbers positive if I can. Subtract the 44 over here, I believe that's 17. And if I add 19 here, 0.2 would be 6, so 13.2, I believe. The 2 would make it the 5/8 to a 6, and then 13 makes it. So yeah, I think that's right. And there's an X on that one. And then I would take the 17 divided by 13.2. So let's see what 17 divided by 13.2 is. Uh, 1.28787 repeating. 1.287 repeating. Sounds suspicious. I'll round to the nearest hundredth as needed. So that's 100, so there's a 7, so that'd go up to a 9. All right, let's check that out, see how we're doing so far. Okay, so that's good. Now, the second part of the question, what is the solution set in interval notation when the problem is solved analytically? So we just said on part A, the altitudes at which clouds will not form is anything below 1.29. So interval notation, remember, 1.29, anything below 1.29, but you can't really go negative, right? Because then you'd be underground. So I think you gotta have your 1.29 to 9. Type an integer or a simplified fraction. Well, that would mean I'd have to come back over here, thinking. And if I multiply them both by 10, that'd be 170, and the bottom would be 132, but that's not simplified. So then if I divide that by 2, is that 85? 60 and 10 is 170. Divide this one by 2, and I think that's 66. So 85 over 66. I'm not feeling very confident here what they're asking in this question. So but the 0 makes sense that I can't at sea level, and then this was the height we came up with. So solve part A. Oh, this said we were supposed to use intersection of graphs to get those. I already did solve it analytically with the equations here. So let's see what we get here. There we go. That was how they wanted to do that problem. So you could have used Desmos to do those two equations and graphed them to see where they intersected. The two equations I'm talking about are these two right there. I just did it algebraically when I did that, but however you do it, that's good. If you can get it, excellent. Good luck.